Here we are finding the area of the surface generated when we revolve the curve y equals x cubed for 0 less than x less than 1 about the x-axis. First of all, remember our surface area formula is the surface area is equal to 2 pi times the integral from a to b of r of x times the square root of 1 plus f prime of x squared dx. Looking at our function, we have written down here in the bottom left, f of x is x cubed, so f prime of x is x squared. Squaring f prime of x and adding 1, we get 1 plus f prime of x squared is 9x plus 4, 9x to the 4th plus 1. When we go to find r of x is the distance from the axis we're revolving around to the function we are revolving, or the curve we are revolving. In other words, represented in red, we have r of x. Now this distance from the x-axis will be our y value, which is equal to x cubed. Now we need to take these values and substitute them into our surface area formula. And we end up with the surface area is equal to the integral from x varies from 0 to 1 of x cubed times 9x to the 4th plus 1. When we want to evaluate this integral, what we're going to end up doing is a u substitution. I want you to notice that under our square root, we have a 4th degree polynomial, and outside of our square root, we have an x cubed dx. So this lends us to think of u as equal to 9x to the 4th plus 1. So if we make that substitution where we let u equal 9x to the 4th plus 1, then du is 36x cubed dx. And when x is equal to 0, we get that u is equal to 1. Likewise, when x equals 1, u equals 10. Making this substitution, we are, noting that we have an x dx, we might solve for that x dx, and we get du is equal to, x dx is equal to du over 36. Making this substitution, we end up with 2 pi times the integral from 1 to 10 of the square root of u du over 36. We can come in and we can cancel this 2, we can cancel this 2 with this 36, and we'll be left with an 18 in the denominator. So we have pi over 18 times the integral from 1 to 10 of u to the 1/2 du. And our reasoning here on expressing the square root u as a fractional exponent is it makes it easier for us to apply the power rule. Now we're ready to evaluate this integral. Our pi over 18 comes out front, and we have a u to the 3/2 times 2/3. But this 2/3 ends up canceling with this 18 and leaving us with a 9 in the bottom. And we also have a 3. Combining those, we have pi over 27 times u to the 3/2. We can express u to the 3/2 as a u times square root u. So we have pi over 27 times u square root u evaluated from u equals 1 to 10. Substituting these values in, or our bounds in, we have pi over 27 times 10 root 10 minus 1 root 1. 1 root 1 is 1. So we have pi over 27 times 10 root 10 minus 1. And distributing the pi over 27, we end up with 10 root 10 times pi all over 27 minus pi over 27.